So another line of evidence to suggest that the ice sheets were actually unstable was that there was a large amount of icebergs that calved off the ice sheets and floated into the North Atlantic, and that can be witnessed based on the dropstones that these icebergs carried. If you're curious about dropstones, you can look at my Glaciers and Glaciology lecture from Geology 101, that's on my playlist there. Or you can just shoot me an email and I'd be happy to tell you about them. So another line of evidence on top of all those three other ones is that this polar and subpolar freshwater caps, that again were the ice sheets, caused a major reduction in the Atlantic Ocean conveyor belt. So the ocean current system that actually moderates the temperatures in the southern Greenland and Europe was distorted. So there was a reduction in that a conveyor belt, if you would. And then lastly, the last line of evidence was that massive and abrupt cooling over much of the northern hemisphere outside of the tropic was experienced with a return to a near ice age climate. So what was going on? Why were these ice sheets in such a disarray despite the colder temperatures? What was going on? So a possible explanation to all of these events, along with the abrupt extinction of the megafauna and the Clovis people, is that the climatic events that occurred were triggered by an extraterrestrial impact at the Younger Dryas boundary around 12,800 years ago. Such an event is supported based on findings in 4 different continents, those being North America, South America, Western Europe, and Western Asia. So they found some evidence here as well, as you're seeing. These dots explain where the findings were made. And also there were some made in the Greenland ice sheet. So most of the sites that support this hypothesis are in North America, as you can see. But there were still some found elsewhere, as I just said and pointed out. So by studying these sites, they were able to pinpoint the event to have happened sometime between 12,835 years and 12,735 years ago. So they had a 100-year span in which they can say that the event occurred, that impact, within the time that the Younger Dryas boundary is set, 12,800 years ago. So that means that it is probably a worldwide time marker, that the impact occurred, and it is probably worldwide since it was found in so many sites across different continents. So the existing evidence suggests that it was a set of many low-density impacts from extraterrestrial objects, not just one large impact. So what we think is that, like the one that fragmented and later airbursted near Jupiter, the one that I showed earlier in the slides, we believe that it was something similar that happened here, but to a much smaller scale. So we do believe that it was a fragmented comet, and that the fragments came and they became airbursts as they came lower into our atmosphere. So the comet exploded widely in the atmosphere somewhere above the northern hemisphere is what we believe, including the Great Lakes region in Canada. So that would be somewhere around here. The Laurentide ice sheet, which is again the ice sheet of North America, destabilized as a result of this, which makes sense, especially around its edges. And that is why it started releasing meltwater from proglacial lakes to the ocean. So it no longer, again, Lake Agassiz, which was somewhere around here, no longer drained towards the Gulf of Mexico, but rather towards Hudson Bay and towards the Arctic Ocean. And also, it's thought that with this explosion of airbursts, there were shock and heat waves that radiated throughout the Earth. And these heat waves would have caused the burning of much of the biomass that we would have seen further in southernmost latitudes, which is why many plants would probably have been killed as well. And with the plants, the bigger mammals. So the soot from the fires that arose after from the heat wave of the impact, and also the ash, was so abundant that the sun rays were blocked for days to weeks, which brought loss of photosynthesis mechanism and hence the death of many plant species as well. So we had initially impacts, which brought destabilizing of the ice sheet, and which brought heat and shock waves. The heat waves themselves caused the fires. The fires caused the soot, which blocked the sun, and by blocking the sun, it brought cooler temperatures as well as prevented any photosynthesis to have been done for those plants that survived the fires. And because they could no longer photosynthesize, they died, and in turn that led to a food shortage for many animals, which themselves perished after that. On top of all those things, in the Greenland ice sheets as well as in 12 sites in the US, there are findings of impact and shock metamorphism. There were nanodiamonds that were caused by an impact, like findings of them, along with the abundance of an out of the ordinary amount of platinum, which is thought to be common in impacting comets. And so these were all keys to pinpointing the event as a set of airbursts from fragmented comet pieces, rather than any other type of impact. Also, the finding of soot and charcoal that was found from the subsequent fires after the impacts helped support this hypothesis. So, again, near the black matte layer, they also found soot and charcoal, which are big tellers of fires. So that would have helped with that hypothesis. So this hypothesis, if proven a theory, would explain a lot about our human history as we know, meaning the reduction in human population in North America, for sure, the change from hunting people to more hunting gatherers, as well as the cultural organizations themselves. Also, they found that in Western Europe, for example, much of the people that lived and made the petroglyphs were reduced, or rather, they couldn't find many more petroglyphs after the young Dryas boundary. And they found that people living near the Middle East, like especially in Syria or so, became more of sedentary and rather agricultural people, like gatherers, instead of hunters. And so we believe that this event could have caused such a change as a human species, per se. And it would be a pretty good predictor of what could happen to us and life as we know it if a similar event were to follow. So we know that things would change very radically in all sorts of ways. Alright, so we are pretty much done covering mass extinctions, and now we're going to go ahead and cover the linkages with other natural hazards, as well as minimizing the impact from impacts. Okay, so as we have seen in the last few slides, the impact or airburst of an asteroid or comet is a direct cause for a number of other natural hazards. And again, as you have probably noticed, what I've gone through in the lecture, things like fires, tsunamis, volcanic eruptions, climate change are for sure some of those. So again, some other ones that I didn't mention within there are earthquakes or mass wasting events, so a lot of landslides and things like that, which makes sense. So tsunamis are caused when an impact occurs in the ocean, which, given how much ocean there is with respect to land, that would be, in truth, most of the times. So we know that there's 70% of the Earth is covered by water, only 30% is covered by continental landmass or even island landmass. And so most of the times an impact is going to happen in the ocean, just by probability. Wildfires are of regional and of global extent have resulted from at least 3 well-documented airbursts or impacts, and those are the KT or KPG boundary, right, 65 million years ago, the Young Dryas boundary, which happened 12,800 years ago, and the Tunguska event, which was in 1908. The heat waves that radiate from the impact site cause superheated clouds of gas and debris that can dry out and then suddenly ignite the living vegetation. So that is how those wildfires occur. We also know that seismic waves from a large impact will most likely activate numerous landslides as well as numerous fault lines. So that would be both on land or underwater in terms of the landslides. So, for example, the asteroid that impacted during the Ch.14 boundary appears to have produced a magnitude 10 earthquake. So, we know that definitely they can destabilize the previously existing fault lines, or rather increase the slippage. And so, we also know that this particular impact caused the mass wasting of the continental slope of North America as far north as the Grand Banks in Newfoundland, Canada. So much of the whole coastline was subject to mass wasting. And again, Newfoundland, it's all the way up in the easternmost part of Canada. It's an island there. It's a big one. We also know that both the impact and the airbursts that we have examined closely and that have aided in the extinctions at the Ch.14 boundary and at the end of the Pleistocene epoch brought about changes in global climate. So impacts on land can inject large quantities of dust into the atmosphere. This dust, combined with smoke from subsequent fires, would result in a global cooling for a number of years after any major impact. And then this would be followed by a period of global warming from the large amounts of greenhouse gases produced both by the impact, so any pulverized or vaporized rock that had carbon in it, and also by the amount of greenhouse gases released by the wildfires. And it's also a hypothesis that impacts can produce volcanic eruptions. So they would do this by causing melting and instability in the Earth's mantle. The melting could result in massive lava eruptions such as flood basalts and hence create large igneous provinces on land. So these provinces contain 100 times more lava than any historic volcanic eruption, just to give you an idea of how big these things can be. And if we find that this hypothesis in fact has a foot, then it could be proven that one or two other of the mass extinctions could be linked to impacts as well. And also, these eruptions themselves appear to have produced global changes to the atmosphere and oceans and contributed to major extinctions of life, as we saw for the late Permian extinction with the Siberian traps. Okay, so now we're looking at minimizing the impact hazard. So, as we know from Chapter 1, the risk of a hazardous event is related to both the probability of that event happening as well as the consequences that it would bring should it take place. So, the consequences include concepts of resilience, of exposure, of vulnerability, of mitigation, of adaptation, of hazard perception, and lastly of social media. And the consequences of a large airburst, based on that, the consequences of a large airburst or direct impact from a large extraterrestrial object several kilometers in diameter, like the one that hit 65 million years ago, for example, would be completely catastrophic. So, although such an event has a 70% chance of occurring in the ocean, the effects of such event would certainly still be felt worldwide, despite it being occurring in the ocean, especially because a very high percentage of the population in the world live near the ocean, live in the coastlines. So an event like that would certainly bring out tsunami waves, which would be devastating for the population, not to mention what it would do to the species aside from humans that were living there. And of course, the severity would also depend on where within the ocean it impacted. But I think we can agree that the overall consequences would constitute a global catastrophe with high potential for mass extinction.